Okay, good morning, everyone. We are excited today to have Generac and Jeremy Niles, along with Sam Eakle here to discuss understanding load management. And we're going to go over some really terrific points about how to sell more Generac systems using the load management features that the Generac system offers. So I'd like to start us off here with Jeremy Niles. He's the channel marketing manager over at Generac, and he's being supported and accompanied today by Sam Eakle, who's the sales application engineering specialist. They're both going to tell us more about the Generac system in general and help us understand a bit more about the load management features within the PWRcell platform. Jeremy, please go ahead and take it away.
Cool. Thank you so much, Aaron, and thank you so much, Jessica, and the whole BayWa team for hosting us today. We've got a big crowd, and so I'm really excited to get to deliver the message to your audience. It's a group of really talented installers, from my experience, and from what I can tell. So before we really get going, I'm just going to tell you what I'm going to tell you before I tell you. Load management is a new development in solar and storage that I think may be as impactful to solar and storage as storage was to solar. It's going to enable not only a lot more business, but a lot more solutions for this technology. And we're going to be getting into this more, what it really means, show you how it works, show you how to sell it, et cetera. But you can imagine the benefit, right? If you're in a competitive market, right, where all the batteries you have available cost the same for you and your competitors. With this tool, load management, under your belt, you're going to be able to sell a higher performance system for less money and hopefully win more bids. Load management is also going to free up and make easier your code compliance issues. If you have to abide by Article 702, for instance, in your jurisdiction, you're going to have a much easier way to install solar and storage for your customers that way. So before we get too much further, this is who I am. Again, my name is Jeremy Niles. I'm the channel marketing manager for Generac's Clean Energy Solutions Group. This is a new business group within Generac. And I'm 100% dedicated to supporting you, our dealers, installers, and distributors, of course, like BayWa. And I do that with programming, with education, and promotions, like I'll be showing you at the end of today's webinar, that are going to help you sell quite a bit, I think. I've been in this space for around 7 years. I actually came to Generac with Pika Energy when we were acquired. It's been a really awesome ride so far. Later on today, I don't have him up here, but I'll be joined by Sam Eakle. He is our sales application engineer, one of them, and he's going to help field technical questions at the end of our program. Sam, if you've ever read our manuals, seen our installation diagrams, or any other technical documentation, he's a key contributor, an author of a lot of it. He also travels a lot, and we're really lucky to have him today. So for all those reasons, I'm actually not putting his contact information up here just to give him a little bit lower profile. But we'll get some good insight from him at the end of today's webinar with all the questions that you're punching into the chat box currently, or during the course of today's webinar. Here's our agenda. First, we're going to take a look at Generac. Then we'll take a look at the product. If you're unfamiliar with the PWRcell system, we'll do a quick kind of high-level overview of the PWRcell system. And then finally, we'll get into the actual discussion. What is the problem and how does load management solve it? And then we're going to show you how to implement these solutions for yourself to help you design better systems that meet your customers' needs better, and ultimately win more work. So let's dive in here. If there's one thing that you should know about Generac, it's that we invented home backup power. Since 1959, we've been making generators that keep people's lights on. And in 1989, we made what's probably the biggest revolution in technical innovation in the generator market, which is the automatic home standby generator, right? Generators just come on when the grid goes down. And since that time, we've been imitated by some of the world's biggest companies, but never duplicated. And we've grown into a $2 billion company with a tens of billions of dollar market cap. We actually just entered the Fortune 500. We have an installed base over 2 million units in North America, which is, interestingly, I think, pretty close to the number of residential solar installations in the United States. Now, that's an incredible history to build on. We're innovating again, and that's what you see today. Solar plus storage, that's what PWRcell is. And of course, we did not invent solar and storage, but I think we're going to perfect it. So let's take a look at how PWRcell looks. This is PWRcell. And on the left, we see the PWRcell battery. This is our energy storage solution. It's an indoor-outdoor capable modular battery that is incredibly easy to install, very powerful, and in its larger configurations has an awful lot of capacity, up to 18 kilowatt hours per battery. It's DC coupled, which means that solar energy goes straight into it with no conversion cost or loss, then right into the inverter. So a very efficient system as well. This is the PWRcell inverter here in the middle. Unlike other systems that use a battery inverter or have inverters built into their batteries for AC coupling schemes, this is the only inverter that you need in this system. So less stuff to install, and again, higher efficiency. It controls both the solar array and battery storage. And because you just have this one single inverter, with solar and battery all using the same DC bus format, this is a plug and play install. Not only fewer components to install, but a much easier configuration process as well. Importantly, this is a transformerless grid forming inverter. What that means is when the grid goes down, in less than 1 second, this inverter is creating its own 240 volt, 60 hertz grid to keep your homes, your clients' homes powered, and their loads running, even through a grid excursion. Last but not least, this is the PWRcell transfer switch. And this is in a whole home power configuration, the interface between your customers' electrical systems and the grid. When the grid goes down, this is what's actually isolating and islanding your client's home from the grid to keep all that energy that is stored and produced by the PWRcell on site. This is how we get up to 9 kilowatts to the continuous power to the entire electrical panel in your client's home. All right, moving on here. This is our solar solution. We call it Power Zone, and because it uses fewer complex components, installation is faster, and the result is a more robust system with fewer points of failure. Basically, if you're familiar with MLPE type systems, we are reducing complex rooftop electronics by up to a factor of 8. In this case, about 6. If you're using an MLPE system that's a module level power electronic system, like a microinverter or a per module optimizer, you would need one of those devices per panel. We just have, in this case, 1 per 6. Sometimes you can get as many as 8 or 9 panels onto a single PV link, usually as few as 2. So a lot less equipment on the roof in this system. And despite having fewer electronics on the roof, one thing that people are frequently afraid they're going to miss out on is shade performance, right? PWRzone still yields excellent shade performance because we work with the solar modules with their bypass diode capabilities. And in full sun, even better performance than per module power electronics. A single string can carry up to 7.5 kilowatts. So you're going to do a lot less, wire runs back to the inverter as well with this system. Overall, I think the theme with PWRcell is less is more when it's all designed to work together. So that's PWRcell in a nutshell. Because Generac owns each component on the roof, we own the inverter, we own the battery, we own the user app experience. And now, like we're talking about today, this sort of AC side load management capability, I think we can pretty safely say that we have the best integrated solution on the market here. And that means something, right? There are results here. It's that integration basically means that we get a lot more power and performance out of our system. You can see how we stack up against our competitors here, names redacted. But if you're comparing to LG, if you're comparing to Enphase storage, if you're comparing to Tesla Powerwall, you're going to get a lot more out of the out of the Generac PWRcell system. So anyway, we have a really incredible system. It's really clean, it's powerful, it's got gobs of capacity. We think it's on the cutting edge. We think this is where the industry is going, more integrated, all from one vendor, that kind of thing. It's winning the spec war, but there's a couple of problems, right? even when we offer the most, people still want more, right? More is expensive. And also, as kind of an aside, code is a tricky thing to manage as well. So let's talk about this problem. Current systems are performance limited, right? If you have a battery and you want to get more power or capacity from that battery, you need to increase the size of that battery or add another battery, right? So if you want to cover more loads of the battery, you need to get more power or capacity from that battery, which means adding another battery. This is an expensive way to add performance. And I might argue, because power and capacity are proportional to the dollars that you spend, you're not actually increasing performance at all, right? You're just adding batteries. We know as a species, really, like how to increase the performance of every other technology that we use, right? Car engines are getting more horsepower with less fuel. Computer processors, solar panels, right? They're all doing more with less these days. And why have we accepted this as the standard for battery backup, that you need to add more to get more? What if there's a way to break free of that one-to-one relationship between dollars and performance, and actually add performance rather than adding dollars or adding batteries? So in today's webinar, we're going to go over some Generac exclusive technology available today, as well as some design strategies that you can integrate to design higher performance systems that provide a better value than anything else on the market. So before we get to that, let's take a look at what's currently going on in the market, what we're accustomed to, basically. What solutions dominate the market and why? And this is basically what we've had going on. And this has been really good, but it's not quite enough. This is what we call a sub-panel system, right? And all of you on the call here today are probably familiar with this. I hope you can see my cursor. Maybe I'll add the pencil here. Basically, in this system, most of the home's loads are located here in the systems or in the home's main panel. And loads that you want to keep protected during a grid excursion are located here in the sub panel. Most systems in the market operate this way, right? You carve off some loads, you keep them protected, and you just make do with the other ones going down when the grid goes down. These have been attractive for a long time because they deburden the installer, right? You don't have to try to sell enough storage to cover everything at home, which is enormously expensive in most cases. You just down select the essential loads, place them in a separate panel, and install just enough battery to cover those. This has worked, okay, for a long time here, but it's not high performance, right? It gets the job done, but only having access to the essentials during an outage is not enough for everyone. What if there's a multi-day outage and your customer encounters a scenario that you didn't plan on, right? It's understandable, right? If you didn't think to put the laundry circuit or the air conditioning or the garage doors or the security system, right, in the essential panel. But maybe after a week or two of power outage, your customer's going to want to wash the sheets or, whatever. Furthermore, if code permits you to put more loads on the sub panel, then the battery can serve simultaneously. A major risk is that you're going to brown or black out the battery, potentially with no recourse. A lot of batteries on the market today don't actually have the ability to recover themselves. That is to, get going again with only solar power available. A lot of times they need the grid to come back up in order to restart. And the only thing worse than a power outage, right, is being in a power outage with a out of commission battery backup system. Imagine how disappointing that might be for your customer. For PWRcell, running the essentials looks a lot better than it does with the competition, right? Because we have a very powerful system. You might actually get to keep your well pump on the protected loads panel, but what about all that other stuff, right? The laundry, the security, the garage doors. How do you tell them that they can't, use those loads during a grid outage? So for folks that could afford it, one solution, as I mentioned before, has just been to add more batteries. And that's just, buying more capacity, buying your way into that solution. This works, but it's a major investment, and all just to meet it, what's probably a once in a while requirement, a once in a while need to have that much power. It would kind of be a waste, right? You're buying a ton of capacity that you won't use very often. Not to mention, you're probably gonna need a lot of room to install a system like this, which comes at a premium these days. So, the world continues to be an unpredictable place. We're all dealing with, spending a lot more time at home, dealing with, crazier and crazier weather, and more people, outside of the usual, sort of greenies and, energy technology nerds, right? Normal people now are, people who watch primetime television are taking a look at solar and storage as a real solution for cost savings and backup power. So to meet the needs of every homeowner, right? Not just the sort of, the super excited. We need to go beyond the sub panel, right? We need to, beyond overbuilt systems. We need to have a higher performance system that can, meet more needs and provide better value. So let's start with a metaphor. Probably feels like I'm really leading you on here, but I think this will be a familiar looking chart, right? Just over a year ago, hard to believe how fast time has gone here. The entire world got engaged in what's probably the biggest conversation about load management ever. But of course, we weren't talking about solar and storage at that time, right? We were talking about how to make the most out of our limited resources in response to coronavirus. And the solution, shouldn't surprise anyone, was load management, right? Instead of building up hospitals all over the world, we came up with load management strategies that allowed us to run our existing hospitals without exceeding capacity. And the idea behind load management for solar and storage is similar, although a lot simpler, and the stakes are much, much lower. Basically, load management allows a solar and storage system to run at capacity while safeguarding against system failure, right? So you can see that here. When you have load management in your system, you prevent it from exceeding system capacity, you can run longer, and you're not going to encounter a potential brown or blackout scenario like you would see here. So rather than overbuy or overbuild a system to meet this level of capacity, which you're not going to see that often, right? We can use load management to intelligently control and sequence the way that loads turn on, right? When we manage loads, we ensure there's always capacity for the highest priority loads. And we can see on the graph here, the big difference, right? Between a system that involves load management, right, blue, and one that does not. Here, obviously, we've exceeded system capacity, which would be extremely detrimental to a solar and storage system's performance. And here we can see that we are, running longer and under capacity the entire time. Basically ensuring that, all loads get powered. The result is more power available for loads that need it, longer runtime, and a system that is going to cost less. Better value all around. So now we know why. Why is load management important? Let's talk about what it is. Broadly speaking, load management technologies prevent the circuits from drawing more than the backup power system can serve. Even though some loads will be prevented from running simultaneously, right? Like maybe the AC unit can't run at the same time as the hot water heater. They'll be able to run independently of each other, okay? So you'll be able to use both those loads during the course of an outage, even if not at the same time. Unless, of course, that load really has no business being on during an outage, stuff like pools, hot tubs, maybe a wood shop or something. So existing load management solutions are not perfect, and they fall into a couple of broad categories. First up, we have the smart panels, and you might be familiar with products coming from companies like Lumen and Span. They fall into this category. Basically, these are, smart or internet-connected distribution panels that replace an existing panel. They're very sleek, but they are complex and they are prohibitively expensive, especially when you consider the amount of electrician labor that it takes to retrofit a home's circuits into one of these panels. Another popular but low-tech form of load management is called load shedding. Load shedding is kind of a DIY approach to this problem that is usually achieved with low voltage relays, and loads are basically a shed when the grid goes down. They turn off. That's it. And you can't use them when the grid is down. You can use them when the grid comes back on, but not during the grid excursion. This is a little bit better than a sub panel because you don't have to install a sub panel, but it's not that much better. Loads are just dropped. You're not really adding that much performance here. Generac, however, has a third option available. It's cheaper and easier to install than a smart panel, and it's much smarter than just load shedding. So let's take a look at what we have here. Here are some of the components that we use in our load management system. We're not going to take a super deep dive on any of these individual components here. I'm going to save that for the installation training that I hope all of you plan on taking after this. But I do want you to be familiar with each of them, in concept as a component of a whole system here. So the PWRcell ATS, we were introduced to this previously. Again, this is what acts as a gateway, as a disconnect between the grid and your customer's home when the grid goes down. Cool feature, internal to the ATS, there is a controller that on its own can control up to 4 HVAC systems via their connected thermostats. So just using, very lightweight thermostat wire, you can actually, in a very elegant fashion, turn off what are usually the heaviest loads in the home without any additional equipment. That's the PWRcell ATS here. Second, we have smart management modules, and these do most of the actual load management in a typical Generac PWRcell system. These can be used to manage individual circuits. They install in line to the home's wiring, so it's incredibly easy to install them, and you can put up to 8 of them on a single system. When the inverter is having a hard time meeting the demand of the loads that transfer to it in the event of an outage, right? What's going to happen is it's going to send a little signal out to the SMMs, and the SMMs will drop the loads that are connected. They drop them in reverse order of priority. So your highest priority managed loads will turn back on first. Lastly, the SureStart accessory drastically reduces locked rotor amps or startup surge current for AC units, meaning that starting a 3-ton AC, even when you have base load in the home, is not going to be any trouble whatsoever for the PWRcell battery. Brings it well within the system's capability. Referring to the previous slide, no one believes me usually when I say how easy SMMs are to install. So I just want to give a couple examples here of what that looks like. You can see here, one common thing is just to kind of install them next to the electrical panel. Another totally acceptable thing to do, excuse me, is just to interrupt the circuits in the home and install them in line, somewhere, between the distribution panel and the actual load. They take, a signal over power line and don't require any auxiliary power. So installing them is incredibly simple. So yeah, again, the only signals they receive from the inverter come over existing wiring. There's no Wi-Fi set up or anything. So a very, very easy installation. Here are some of those components again, but arranged in the way that you would probably actually see them. When the grid goes down, the automatic transfer switch, or ATS, is going to start islanding away from the grid. So you see that we lose this connection right here. Essential loads are prioritized and should never lose power. That's what we see here. The essentials are going to stay up. They're going to stay green through everything that we see here. Non-essential loads are going to share the balance of power available and may have to take turns cycling depending on how much power is available. If you're paying attention, I think you would have seen that, the hot water being on, then turning off, and the AC unit turning on because it's, going to be a higher priority than the hot water heater here. The SMMs, our smart management modules, automatically control these managed loads, pausing them to yield power to higher priority loads. We'll take a look at this functionality in greater depth here shortly. Let's see. Oh, there we go. There's the air conditioning turning off, the hot water heater getting power now that's available. So let's take a look at another visual example that shows the difference between a sub-panel setup and a load managed or whole home setup. On the right, you can see that we have a backup panel, 9 kilowatts worth of loads. And on the left, you can see that we also are protecting 9 kilowatts worth of loads. The difference is that when you use a load management system, you're not restricted to any particular set of loads. You see that the loads here stay static. The only restriction is that the loads do not exceed the system's backup capacity, which for our largest battery with 6 battery modules is 9 kilowatts. In this case, as long as loads, don't exceed 9 kilowatts, the home circuits are going to function as normal, and the homeowner will not have to change their behavior whatsoever. And this is a major benefit of load management. Your customer will be able to operate within the normal range, just turning on the things that they always turn on, and they're going to have access to all their loads. And they'll do this so safe with the knowledge that their system can't be overwhelmed by any combination of loads. Again, some loads might be unavailable to run simultaneously, but nothing is going to be unavailable altogether. this is a higher performance setup than a sub-panel system like this, where you just get these static loads. So let's take a look at that functionality one more time. What happens when loads do exceed the system's capacity, 9 kilowatts, for example? Like, let's say when the hot water heater and the AC unit decide that they want to cycle at the same time that the essentials are running, right? The lights, the TV, the fridge. You can see that our circuits are divided up here, right? We have managed down here with SMMs, and we have essential up here with no SMMs, unmanaged. These just run, without intervention. So you can see that the air conditioner and the hot water heater are being managed by SMMs. The hot water heater is priority number 2. And in this example, the hot water heater, we're going to see, is currently drawing power. And then the air conditioner is going to try and start. This stresses out the system, okay? The system recognizes that trying to run both of these big loads at once is gonna overwhelm it. So what happens is the inverter emits a frequency signal. Inverter's over here, by the way. We can't see this, but it's supplying the power, so it knows what's happening downstream. It's going to emit a frequency signal that is going to trigger the SMMs to pause, and it's going to repower in order of priority, so that the AC unit is going to power on first, and then after a brief recovery period, the rest of these managed circuits are going to come back on. So in this case, the hot water heater yields to the AC unit because it has a higher priority than the hot water heater. But if your customer is unsatisfied with this, after a few outage experiences, they're missing the cycles in their hot water heater, it's pretty easy for you, the installer, to come back and reprioritize these to, assign the hot water heater as priority 1, AC unit as number 2. Lower priority circuits are always going to have to wait for higher priority circuits to turn, or not always, but may have to wait for these higher priority circuits to turn off before power is available. In this case, what tripped this up was probably just the high startup draw from the AC unit. And I bet that after that was over, both could probably run simultaneously. Important to note, these essential loads during this entire process were never interrupted. So really, this is just a battle for remaining energy for by managed loads. So the essentials are always going to be up. But these two might have to negotiate for remaining power. It's also worth noting that load management can provide a clean solution to compliance problems. If your AHJ, for instance, enforces NEC 702, it has to do with how much backup power you need to make available for the given loads in a given scenario. If your AHJ has been enforcing 702, you may have had to been very strict with how you sized your subpanel, or you may have been forced to sell more storage than you really wanted to. Maybe you even lost jobs because of this. Well, if you have been unfamiliar with load management up to this point, you may have also been unfamiliar with this other part of the code, part B, which basically says that if a load management system is in use, then the battery only needs to be sized for the maximum transferred load, the maximum load that will be connected by the load management system. And because a load management system prevents local load from exceeding the battery's capacity or capability, that means that basically all you have to do is size your unmanaged essential loads to be, at or under your battery's power, and then manage the rest. It's that easy. You can keep everything else, all the loads in one panel, and still meet code when you employ load management. So that's a bit about, what load management is, how it works, why it's important. How are you going to use this knowledge? How are you going to use it to positively impact your business? Well, I hope that you're going to be able to put it to work to win more work by offering a higher performance system at a better value to your customers. So let's see how we go about this process. In this section, we're going to cover some of the processes that you can employ to start selling and designing load management systems that compete with and outperform unmanaged systems of equal and even larger size. Here are the basic steps, okay? You're on your sales call. The first thing you want to do is gather information. Whether you're doing sales consults in person or over the phone or on Zoom, really, it's all the same. Get from your customer a list of the 20 or the 240 volt loads in their home. These are the things that you'll have the option to manage. All of the 120 volt loads in the home will be unmanaged. So all receptacles, all lighting, Most small appliances in the home are going to be unmanaged, but you'll want to make very careful note of what the 240 volt loads are in the home, because those will be the ones that you're going to, pare down for management. Next, you're going to want to work with your client to determine which of those loads are essential. Maslow's hierarchy applies here: food, water, security, shelter. These are the things that you're going to want to prioritize. And this is going to be a time for managing expectations as well. All right. Next, you're going to want to enter your load data, right? You're going to want to play around with our load sizing worksheet to make sure that the loads that you want to manage are going to fit within your energy storage system's capabilities. And then finally, you're going to want to compare. Show them, your client, what a PWRcell system can do for the money versus a competitor. And I think we're going to come out on top. Okay, so step one. When you go to your client's home, it's important to gather as much information as possible. You're already accustomed to going in, getting utility information, roof measurements, that kind of thing on solar sales calls. But when you start selling solar storage, you're going to have to go a little bit further. Not too much further, but a little bit. So this is basically the basics. Make a list and take photos to document all the loads in the home. Right down to the number and type of light bulbs. This, more information is better. Taking photos or making record of the distribution panel, like we see here, a nice photo showing, the size of breaker connected to each one of the loads in the home is excellent, as well as getting recordings of data labels from large appliances like hot water heaters and AC units, right? So you can see what their startup load characteristics are, run load characteristics, all those things. These are going to factor into your load planning. Next, this is really important. Talk with your client about what's important to them. What time of year do they expect outages? Are they going to be wind related, snow related, heat related? And what kind of outages are they worried about? Are they going to be driven by utility policy, by hurricanes? That kind of information is going to probably have a big impact on your strategy and can potentially unlock some additional performance or cost savings, right? Because let's say that your client's outages only occur in the fall and winter. Let's say that they're on public water supply and that they live in, just sort of a single story, one family home. In that case, you're not going to have to worry about sizing the system to run a well pump or an AC unit, right? Because you don't need the AC in the fall and the winter. You can probably get away with less battery capacity and less load management in this scenario. However, if they live in PG&E territory, let's say they drive an electric vehicle, they have a well pump, AC units, they anticipate wildfires in the future, right, during hot, dry seasons, you may be in for a more intensive load prioritization process. So every case is different, but always gathering more information and thinking about how you can use that strategically is going to help you in the long run. So let's imagine now we took good notes on our sales call. We have our list of loads here that we've gathered from the customer. Let's start prioritizing them, right? You spoke to your customer, you know what their needs are, and we can get down to business. And just keep in mind that, again, people's needs vary, geography, installed applications vary. This example is just an example. We're going to connect you with a real tool that you can use for this purpose at the end of the show, or maybe in your follow-up email. So let's get started. Let's take a look at this hypothetical list of loads. First up is lights. Everybody needs lights, right? And furthermore, lights are a 120 volt load typically. So even if we wanted to manage them, which we wouldn't, we couldn't. These are going to be a shoe-in for the essential or unmanaged load category. All right, next is outlets. Similar to lights, receptacles are something we always want to have available. That's how we get our Wi-Fi, our security, lamps, cell phones, laptops, etc., all staying powered. So we're going to put the home's outlets in the essential or unmanaged load category. Next, we've got laundry. This is not here because it's a priority, right? Laundry is not something you necessarily need during every outage, but because it's one of the heftier 120 volt loads that you're going to encounter, it's got to go in the essential category. And you should definitely talk to your customer about maybe not using precious battery energy to dry clothes during a power outage, even though they can. Next up, we've got the kitchen here. In an outage, again, getting right back to basics, we got to prioritize the stuff that matters: food, water, and shelter. We definitely need to keep the fridge running. So it is important to note that, in the kitchen bucket, we might have sometimes like an electric range that might be drawing up to 5,000 watts on its own. That might also be on its own circuit. But, it's a big load, and it's one you're probably going to want to have, be powered during an outage in any case. But do consider that. Do consider putting that into the managed category, even though it's in the kitchen. Next up, we have our hot water heater. If your client has a tank type hot water heater, you can kind of think about that appliance as a energy storage device. It's just storing thermal energy, right? It's going to keep that water hot, maybe, less by a few degrees, even if it misses a heating cycle or two, right? So just like we showed in the animated example earlier, this is an ideal load to manage with an SMM. Manage the hot water heater by default. Every time you're going to take your energy liability down by a huge margin when you do this. Okay, now the well pump. This is a big load, but thinking back to basics, you really want to have your food, water, that kind of thing covered. So we're going to be putting the well pump in the essentials category. We don't ever want to be in a situation where the HVAC system, for instance, is getting priority over hydration and basic hygiene, that kind of thing. All right, next up, we got the hot tub. This is a prime offender. Where might we put this? We might actually want to go beyond managing this load in this case. We haven't talked about this capability yet. But the smart management modules actually allow you to shed loads, to lock them out, basically prevent them from running when the grid is down. So that's what we're going to do with this one. And to be clear, you could keep this on. You could make this a managed load. You could even make it an essential load. But I think that your priorities would probably need to be reevaluated in that case. Next here, we have our sump pump. I think you're going to regret not making this one an essential load, because if it needs power and can't get to it, you might wind up with some damage in the basement that you would definitely want to avoid. Okay, last up here, we have our AC unit. Our system is unique because it features enough power to start a 310 AC unit. And this is great because for many folks in warmer parts of the country, that classifies it as an essential load. That said, I would do everything possible to put this appliance in the managed category, either using the automatic transfer switches, built-in HVAC management capability, or using an SMM, whichever one you want to use. I would do this because it's a big load. It can gobble up energy pretty quick and run down that battery. Remember, if you can run control wire from your thermostat to the ATS, this is the most elegant way to do it, but you can also use an SMM inline. So, all right, that's our rough load plan. Let's check our work here. So this right here is a screenshot of an Excel tool that we make available to our installers. You can find this on our website very easily, and I'm going to work with Aaron and Jessica here to get this to you in your follow-up email. It's pretty intuitive, and I think that you'll find it easy to use. So I have this information here pre-filled. What you're going to do is just put your project information up top here. Your name, phone, service size, address, that kind of thing for the project. And then we're going to start entering load data on the left here. That's what this area is for, is entering all the loads that exist in the home. This is meant to be a square, by the way. Right. This is where you put your project information, and then down here is where you enter your load information. Most of the appliances that you're going to be working with are already listed. These are all defaults that come with the sheet. So lighting receptacles, dishwasher, kitchen stuff, well pump of different sizes, and then some big fixed appliances that you might want to consider locking out are available down here. Basically, we try and represent all the different sizes of well pumps and AC units and make educated guesses for you about their load characteristics. Of course, you can modify all of these load characteristics as well as toggle in this column whether or not those loads are going to be managed or not, or locked out. Keep track of the results that you get out here on the right-hand side. This cell showing your NEC calculated load is going to be highlighted in green right there. If your chosen battery configuration can handle the unmanaged load that you've entered. You're going to, well, it's just, I put a lot of ink on here now. Let's skip ahead if we can. Skip. Is that going to go away? How do I clear this out? There we go. All right, so you're going to keep track of your results here on this side of things, and you're going to define your battery right there. So this is just a closer look at those results here. Basically, if this cell is highlighted in red, then that means that your battery that you defined here can't handle the load. Of course, what you can do is just go back in, select more of these loads to be managed, or increase the number of battery modules that you install here. You can install anywhere between 3 and 12 modules, and it'll also spit out a duration number right here. Rewinding a second, remember that our 6 module battery maxes out at 9 kilowatts. Okay, so in this scenario where we have all these loads that we selected, our calculated load with the management scheme that we've defined is going to be 7.5 kilowatts. So if we have 9 kilowatts to play with, we still have plenty of overhead here. No worries. We can even take this number down to 5, I think, and still be in good shape. That depends on the price sensitivity of your customer, what you can get away with based on the climate and specific load factors that you're dealing with. That's totally up to you. Next, we have this ESS duration figure right here, giving us 12 hours of duration. Oopsie. And it's important to know that is a kind of a guesstimate. It assumes a flat 20% utilization rate for your clients' essential circuits. In other words, it assumes that if they're just going to run their essential and unmanaged loads 20% of the day, until the battery is drained. That's probably not the way that your customer actually uses their appliances, but this is just kind of a good ballpark figure that you can use to gauge your customer's reaction to help you sell additional storage to achieve longer durations if your customer is concerned about that. However, in my opinion, 12 hours is a great number. It's plenty for most backup power situations, because it's going to be enough to get your client all the way through the night and into the next day when the sun can rise, hit those solar panels and recharge their battery. So last step here, let's compare. We're not going to show you any dollar figures, but we can show you what equipment is going to yield what result. And you can take that information to your distributor for a quote. So again, we've got BayWa here. They're going to be a great resource for you. Maybe even as soon as we hang up, you can check in with Aaron, with Jessica. They'll be able to connect you with detailed pricing information for all the stuff we're looking at here today. Because PWRcell uses load management, we're able to put our single battery to better use. That's what we're seeing here. We're seeing a multi-battery system over here, one battery over here. That means basically that you can sell fewer but higher performance batteries to cover a larger number of loads. We're fully utilizing our battery capacity and preventing overload thanks to our battery management technology. If you were to go with, say, an AC coupled battery like Tesla, you might need 4 or 5 batteries to cover the same loads in a single panel that our single battery would cover because it has load management. More commonly, you're not going to see that kind of apples to apples comparison. You're going to see 1 or 2 batteries with a sub panel, that kind of thing. In this case, you're still typically quoting, buying, trying to sell multiple batteries, which is too much capacity, and you're still covering just part of the loads in the home, in that sub panel. Even with all those batteries, some unfortunate coincidence could black out that system, right? If some combination of loads turned on in here, and depending on the battery manufacturer you're going with, that may or may not be recoverable over the course of that grid excursion. You might be stuck without power when the grid's down if you don't have load management. So let's break down the big differences here. Number of batteries. First up, our single battery PWRcell M6 in this case protects nearly twice the loads that 3 Tesla Powerwall 2s can protect. So to be clear, Not saying that our single battery is more powerful than 3 Teslas, just that because we have load management, we can protect, we can serve or service more loads than an alternative battery can. Batteries aren't cheap, so I think you're always going to win by quoting fewer but higher performance batteries. That's going to be a good strategy for your salespeople. Next, complexity of installation. So yes, I think if you break down, the bill of materials that you might get from BayWa, you'll see that we have more lines, but it's a simpler installation. It's more modular. There's no heavy lift. You're going to need fewer people on site. No part of this system weighs more than 75 pounds. A lot of our competitors have large monolithic batteries that are going to need a fork jack, multiple people on site, generally more of a hassle to install. Capacity, finally, the Tesla system has a lot of capacity, right? But especially when you do multiple batteries, right? But this is stranded energy that you pay for, but you're not likely to use, day to day. It's kind of like carrying around a gallon of water as your water bottle. You probably just don't need all that. In the event of an outage or at any point. 12 hours of backup duration, I think, is more than enough for 99% of outages. They're lasting, 3 to 4 hours. It's only really desirable to have more when multi-day outages and low sun are expected to coincide, right? Big winter outages, that kind of thing. And in that case, you can always add a second power cell to get, a full 24 hours plus of backup power, plus the benefit of system overload protection coming from load management. So this is what a higher performance system looks like. It's better integrated. It's coming from one manufacturer. It's kind of a unified experience for your customers. So a much better thing overall. That's it. That's the presentation. Generac has a product for you that's going to perform better. It's going to be better for your customers, and it's going to be easier to install and service. It's not just that we have an end-to-end solution, our product, but we also have an end-to-end solution for you. We are your business partner. We're never your competitor. And we are the recognized leader in home backup power, coming from our long heritage in home standby generators. We're the brand your customer is already thinking about when they need energy security, when they need backup power for their home. So special offer to you. When you become a power partner, not only are we going to give you the standard offer of, pre-qualified leads that we share with you, that we actually book and, make as appointments for you. We're going to start feeding you leads. We're going to deliver you this whole system and, then provide you excellent service on the back end. Any component of the system that you have trouble with, whether it's solar, battery, inverter, load management, whatever, you only have one number to call, which is a pretty big deal. I know our customers can't say, I know that our competitors can't say the same thing. And for a limited time, to sweeten the deal, we have a special incentive. We have a $1,000 welcome offer. Just like signing up for a new credit card, we're going to give you $1,000 cash back on your first installation. This is really cash back. It's a check in the mail, and it should be enough to offset the cost of training your team, putting them through our certification process, and give you a little bit of extra cushion on your inaugural installation. So please visit the website shown down here, generac.com/PowerCell/welcome offer, to redeem that offer. And I'll work also with the team at BayWa to get you a handout that'll explain in more detail how to take advantage. So that's it. Let's move on to questions. I want to thank everyone for your time. I know you could be out, doing your job, but you spent the time with us, and I really appreciate that. So if you have questions, let's get to them.
Yeah, thank you so much, Jeremy. There was a lot of really great information in there, and we did get some terrific questions in the Q&A section. If anybody who is attending the webinar today has additional questions, please go ahead and drop them in the Q&A, and we'll be getting to as many as we can in the next few minutes here. So the first question, I think, should be an easy one to start off with. Could a different brand of string inverter be used with the system? Why not? Yeah,
that's a great question, and I'm actually going to kick that over to Sam, if you're online there.
Yeah. Hi there, folks. No, a different brand of inverter cannot be used on the system, though we will be working on functionality to incorporate like an AC coupling with, say, like an existing end-phase system. Currently, you cannot use a power cell battery with a different inverter system.
Yeah, and so yeah, keep your ears open for that update. But also, maybe more importantly, is the load management capability in our system is something that I doubt will ever be, replicated with another manufacturer. The signal that we send down the power line to tell our SMMs to drop off, or to tell our ATS to, turn the thermostats off to manage those HVAC systems, is, I think, proprietary to Generac and not something that other manufacturers will be adopting.
Thank you. Okay, for the next question, how easy is it to change priorities within the SMMs? Are they set and kept the same way, or can they be changed easily halfway through an outage?
Yeah, good question. It's pretty easy to change the priority on them. It's just a dial on the SMM if you remove the cover, and you can change it in an outage. Obviously, the system is going to be managing those loads as you're islanded with the PWRcell system. So, you just want to make sure you're doing that at the right time for yourself. But yeah, it's as simple as turning a dial on the SMM. It's ideal to set it and leave it, but you can change it midway through.
Fantastic. Okay, and then we had another question come in asking about a customer with a client interested in storage primarily for a sump pump, but they only have room on the roof for a 6.4 kW system. Does Generac have any smaller systems available?
No, the 7.6 inverter is what we have right now, and but you don't. That's fine if you only want to install 6.4 kW of solar into that inverter. That's fine. You just want to make sure that you're sizing your battery. In other words, you're installing enough battery modules to accommodate that load. And that would be the main thing.
Yeah, absolutely. You don't have to hit that. You don't have to max out on the PVDC side. System, you can install a system that's right for your customer. It's a very flexible situation when you're working with Generac. So, okay. So next question, how long is Generac covering the manipulation of the power needs of the larger load, or I'm sorry, excuse me, how is Generac covering their manipulation of the power needs of larger load appliances to ensure that SMMs aren't going to damage the down the line appliances that are being paused when they are demanding power? I imagine that there's a request for power and then a pause and then a resending of power. So maybe we should clear up a little bit on how the SMMs work.
Sure. So the SMMs work by the way, the SMMs have been around with Generac for a while. We've had this product for a while, working with our generator products. So just the same way that they work with our generators, when power drops out, the inverter will toggle the frequency and signal those SMMs to shed load, and then by the priority that has been set, those SMMs will allow that load to come back on the system based on available capacity, continuous power. So there really isn't a problem with the appliance getting damaged down the line. It'll either get shut on or it'll get shut off. The SMM is really just a contactor that gets toggled by frequency.
Thanks. So next question here. My sales area has a one-to-one net metering policy. So the utility stores excess power from us. We also don't lose power frequently. Are there any financial advantages to PWRcell other than just for backup during outages?
Go ahead.
Yeah, I was going to say, fewer for sure. If you have a utility that is doing the right thing, maintaining one-for-one net metering, you don't experience many outages, that's great. I think that's lucky. You should cherish that for sure. I don't think you can bet on that happening forever and staying that way. And so all I can say, for advantages, for energy storage, if you're not dealing with time of use currently, if your energy rates aren't fluctuating and there's nothing to be gained from storing cheap energy, using it when it gets expensive, is that I think there is a lot of benefit to installing today a system that'll make energy storage later on simple, right? This is a 25-year investment, and I don't think that anyone has a really great picture of what what's going to be going on in 25 years from today, especially with regard to the grid, to energy technology, that kind of thing. So I think it's going to cost a couple $100 more probably to install a hybrid islanding type inverter over a bare bones PV only inverter. But I do think that it will pay dividends downstream when you want to come back to that customer and add a battery, make that installation simpler and higher performance, make it the best installation possible, rather than sort of a bolt-on retrofit that might leave a few things to be desired.
Great. The next couple of questions have to do with system limitations. I'll go ahead and pop 3 questions into one statement here.
Cool.
So can you confirm that in a power outage, the battery backup will supply power to enable the solar side of the system to continue functioning? And then along with that, can you confirm whether or not you can have 2 inverters with a single power cell? So I think the question is there, could you pair 2 inverters with 1 battery system? And while you're answering those, can you just restate what's the maximum amount of solar energy that you can pair with a single power cell inverter?
Yeah, I'll start with the last question first. So the maximum amount of solar that you can pair with 1 inverter, I mean, it's up to 15 kW if you want. You can double it up. It's just, you need to look at the return on the investment and what are the needs of the customer. What's the battery attachment, and are you going to be cycling that battery on a daily basis? If you install too much solar on the roof or on a ground array, and you're not using that power, then it just is wasted and it gets clipped. But if you are, say, oversizing the array on purpose because that customer is going to be cycling a full 6 module battery on a daily basis, that can make a lot of sense, because you can be then the following day, say your battery's depleted down to whatever you set the reserve to be. That oversized array can then charge the battery and export to the house loads and the grid at the same time. In an outage, the system will go into island mode, and during the day, if that happens, most certainly PV power will be available for you, and then the battery will kick in as the load demand exceeds what solar is producing. And so in a multi-day outage, that's how you ride through that. You can have a situation where, say, power goes out. Maybe that happens during the daytime, so PV is covering a lot of those loads. As the sun goes down, the battery kicks in. At a certain point, let's say the battery drains down to the maximum reserve that you set. It comes default to go to sleep at 2% state of charge. At that point, it'll go to sleep. The system will turn off, but the battery will conduct a power search every hour for 4 minutes. And once it detects that in a power search that PV is available again, the system will wake up and the battery will begin charging again from the sun, and the system will wake up and begin powering your loads. It'll start all over again. And let's see, what was am I missing a question there?
I think the last one was, can you connect 2 inverters to a single?
Right. So yeah, you cannot have 1 battery connected to 2 inverters. You can certainly connect more than 1 inverter at one site, but right now they're going to need to be isolated systems. You can have it where, and this is fairly common for sites that decide they want a rather large array. They want to export as much as possible and also have backup capabilities. They'll set 1 inverter up as a grid tied solar only inverter, and then the other one will be the sort of like backup system inverter. You can put the grid connection for those inverters into a combiner box, but then the protected loads or the backup wiring for those inverters would need to be separated if both were going to be trying to contribute to the backup of the home.
Yeah, and we have really an extensive library of installation support materials, not just manuals, but also what we call pre-approved system diagrams, single line diagrams that Sam and his team have made up that basically if you follow them or use them at least as the foundation for your design, you're going to have very few issues with your design. But yeah, multi-inverter systems, multi-battery systems, all those different permutations of what's possible with our system are already more or less defined, and you can find those at generac.com in our installer support section.
Fantastic. We are just a couple minutes over, but there was a couple of questions related to time of use scenarios and whether or not the PWRcell system was capable of operating within zero export time of use restrictions.
Yeah.
And it's super easy. We have on the face of our inverter. Sorry, Sam.
Go ahead.
We've got this display right here with these buttons. Setting your inverter as an installer from stock standard just net export to a zero export mode like you'd install in Hawaii, or where you have maybe a malicious utility, or setting up in a self-supply mode that you would use to absolutely minimize the amount of energy that you send back to the grid, where maybe you don't have that nice 1-for-1 net metering agreement, maybe where you have to sell back at a bulk rate. That's all done with a couple clicks. Literally, I think you can set that up with probably less than 5 clicks. And Sam, you can probably lend some color there, but it's incredibly easy.
Yeah. So we have 32 preset time of use schedules. And there's a program guide on our website where you can access those schedules and see how they perform. We essentially toggle between a couple of system modes. Typically, it's like clean backup and self-supply to achieve mitigation there. We'll, on a few of those schedules, we'll throw in priority backup or cell mode as well. But just as Jeremy said, really easy to program any one of those presets on your system such that it'll operate on that schedule. And then anytime you want to override that schedule, it's as simple as walking up to the screen and changing the system mode to one that you want to operate in for that time. And then that schedule will pick back up again at its next scheduled change. And if you want to disable it, again, really easy to do from the display. And then zero export is achieved by setting the inverter to export override. Again, for markets like Hawaii and places where you're not allowed to export. So yeah, nice and simple.
Yeah, and it looks like there were a few iterations of the same question about pairing the PWRcell system with in-phase microinverters or an in-phase combiner that's already been installed. Just want to reiterate that this is not an AC coupled solution; it's a DC coupled solution. So in that case, the customer. Well, Jeremy, do you want to say any more about that, or Sam?
I'd say just keep your ears open, hang tight.
Yeah, exactly. Okay, I think that we got through most of the. One just popped in. What's the lead time? Go ahead and contact our sales team. I believe we have the batteries in stock currently, and we can turn those around to you fairly quickly. So reach out to the BayWa sales team, that member that you work with on a regular basis, to get your orders in place and get your allocation set for any projects that you have on the horizon.
Well, Aaron, thank you so much for hosting us. Jessica, thank you so much. It's been a pleasure. And to everyone in the audience, again, I really appreciate you spending your day with us when you could be out there on a nice roof or designing one of our systems. So thank you so much.
Yeah, thank you all.